Hi, I'm Mike Rowan. Welcome to Part 9 of Retro Printing for Fun and Profit, sharing new and old printers with new and old computers. This is our final episode, and in this episode we will look at using the Raspberry Pi's built-in UART for the serial connection instead of a USB serial adapter. I haven't taken the time to install the GPIO header pins on my Raspberry Pi Zero yet, so for this demonstration I'm going to be using a Raspberry Pi 3B Plus. Now the GPIO pins are identical to those on the Raspberry Pi Zero, and one of the nice features of the Raspberry Pi is it has a built-in UART. So serial I/O is available on GPIO pins 14 and 15. They are transmit and receive. But there's a catch. The Raspberry Pi uses 3.3 volt logic. If we were to connect the color computer to it, the RS-232 voltage levels from the serial port would fry the Raspberry Pi's GPIO. But thankfully, there are readily available modules to convert the voltages and give you a nice DB9 serial connection. The module uses 3.3 volts logic to the Raspberry Pi and RS-232 levels on the DB9 side. A closer look at the converter module and you can see that it has 4 pins that connect to the Raspberry Pi. There's a transmit that connects to the TXD line of our GPIO pins. And then we have the RX line which connects to the RXD pin on the Raspberry Pi. Then there's ground that we connect to the ground pin on the GPIO connector. And finally we have a VCC which connects to 5 volt line on the Raspberry Pi. The nice thing is that all of these pins are located in a row, right next to each other. And there's just one more thing we have to address. If you remember, we need to supply the DTR signal from the Raspberry Pi to the color computer on pin 2. But this module doesn't provide voltages to the other pins. So we need to add a wire to supply a positive voltage on pin 4 of the DB9 connector. So on the underside of the module, I tacked on a wire from pin 4 of the DB9 to the 5 volt VCC pin. So let's plug this into the Raspberry Pi now, get it hooked up, and see how it works. So here's the Raspberry Pi 3 GPIO pins, just as they would be on a Raspberry Pi Zero. The pins have been connected, and I've connected my converter module much the same way, just by plugging the pins in. 5 volts, ground, transmit, and receive. Now all we need to do is plug our color computer cable into it and connect power, and we'll try it out. I've opened a couple of terminal windows and both of them are logged into our Raspberry Pi 3B Plus. Now the same software is installed on this as we installed on our Raspberry Pi Zero. So it all works identically. So we have cups installed. You can take a look. I've got a printer defined, named it slightly different on here. That's my laser printer. And also before we were using TTY USB 0 as our serial device, but now we're using the built-in UART. So it's kind of easy to find the USB ports because they don't show up until you actually plug the device in, and then they're automatically added in /dev. But this device is there all the time because it's an integrated serial port. So if we cd to /dev, I can tell you that the device we're going to be using is serial 0. Now when I list it out, you'll see that it's a link. It's a symbolic link. That's what the L is for here. So serial 0 is a link to the device TTYS0. And a little history behind this. It's not real clear to me whether it was certain versions of the Raspberry Pi or if it was with OS version differences, but as I understand it, this device wasn't always named TTYS0. On other times it'd be called something else. And this led to confusion and of course some software compatibility issues because the device wasn't the same on everywhere that you loaded your software. So to get around that, they created this serial 0 link. So if we reference /dev/serial0, it won't matter what the underlying device is called. We could use TTYS0, but we're going to stick with the serial 0 for compatibility. So let us go back to our home directory, let us go back to our home directory, and then I'll cd to .prw. Let me run prwatch status, because prwatch is installed. Okay, make sure it's not running. So we will edit the configuration file, prwatch.conf, and we need to set this up to use the GPIO serial. So by default it's using TTY USB 0. We're going to get rid of that and put in serial 0. That'll be our device. Oops, I got an extra colon in there. We'll keep it at 9600 bits per second from the color computer. And then I need to give it the printer name, which I already forgot. So I will grab that, paste it into the file. All right, so we've got /dev/serial0. That is our GPIO connected UART serial port on the GPIO pins. We're going to be at 9600, and we will use the laser printer as our output. So we'll save that file. Just double check. Yep, there we are, serial 0, 9600, and our brother laser printer. So I'll CD out of there now, and PR watch again, status, not running, so let's start it. PR watch start. Now you'll notice a message here. STTY serial 0 unable to perform all requested operations. Apparently this does not support 2 stop bits, and it's the 2 stop bit setting that I have in there that is creating this message. However, it doesn't affect the operation of the program or the software. I may ultimately drop that from the code, but don't get excited. If you see that message, just ignore it. It's going to work fine. If we do a PR watch status, we can see that our programs are running. So we've got it plugged into the color computer. I've got the color computer set for 9600. Let's do an L list and see if we get a printout. Let's do an L list and send the data. And the printer is starting to print. All right, so that worked. Our print was successful. So you can see that as an alternative to a USB to serial adapter, you can use the built-in UART with the little converter module that converts from 3.3 to 5 volts. And it works just as well. In fact, I found with the USB adapter, the slowest I could go was about 1200. But on the GPIO, I could go as low as 600. And it should work. So that would be the default speed if you wanted to print that slow or had an application that went that slow. You might prefer using the GPIO connected UART pins rather than a USB serial device. Well, we've come to the end of the series. I hope that you enjoyed it and learned something in the process. In the future, I hope to push this project further by supporting graphic printing. Until the next time I make a video series, thanks for watching.